Jai Hind. I am Cadet Jaideep Bhavsab Dushi, studying in class 11 from Padma Shri Dr. Vittal Rao Vike Patil Sainik School, Loni.
Jai Hind. I am Cadet Samar Chandrakant Paul Budhe, studying in class 11 in Padma Shri Dr. Vittal Rao Vike Patil Sainik School, Loni.
Today, I have made this model for visualization of three-dimensional space. When we draw three-dimensional figures on blackboard, it is very difficult for students to understand it. So, for that purpose, I have made this simple three-dimensional model. To construct it, I have used three different planes by arranging them in such a manner that they are perpendicular to each other. To understand the concepts related to it by using the model. Now, the first concept is octants. When the three planes are arranged in such a manner that they are perpendicular to each other, 8 different octants are formed. Now, you can clearly see that it is first octant, it is second octant, it is third octant, it is fourth octant, and here downside it is fifth octant, it is sixth octant, it is seventh octant, and it is eighth octant. Now the second concept related to this model is axes and planes. When we arrange three planes in such a manner that they are perpendicular to each other, three different axes are formed. The horizontal one is called x-axis as is mentioned here. The second horizontal is called as y-axis, and the vertical one is called z-axis. And the plane formed due to x-axis and y-axis is called as xy plane. The plane formed due to y-axis and z-axis is called as yz plane. And the plane formed due to x-axis and z-axis is called as xz plane, as it is all mentioned it here. Now the third concept is point in 3D space. For that purpose, I have represented a point in 3D space by arranging the lines perpendicular to yz plane, to xz plane and xy plane, and through that process I get a point in 3D space. Now the next concept is direction ratio of line. Now here we can clearly see that it is a line in 3D space. If any line is parallel to this line, then this line is called as direction ratio of that line. The next concept is direction angle and direction cosine of the line drawn from origin. Now here we can clearly see this line is drawn from origin. When this line makes an angle with x-axis, it is called as alpha. When this line makes an angle with y-axis, it is called as beta. And when this line makes an angle with z-axis, it is called as gamma. And this alpha, beta and gamma are direction angles of this line. When we take cosine of the direction angles of this line, we get direction cosine of this line. The next concept is plane in 3D space. Now here we can clearly see that this plane is parallel to xy plane. When we move this plane from up to down or down to up, only the coordinates of x-axis are going to change. So therefore the equation of this plane comes, the z coordinates are going to change. So the equation comes out of this plane is z is equals to c, where c is any constant number. Now next, when this plane is parallel to yz plane, and when we move it horizontally, only the coordinates of x are going to change. Then the equation of this plane comes out to be x is equals to c, where c is any constant number. Next, when this plane is parallel to xz plane, and when we move it horizontally, the coordinates of y are going to change. So the equation of this plane comes out to be y is equals to c, where c is any constant number. Now the next concept is foot of perpendicular of point in 3D space. When we drop a perpendicular from this point on this plane, then that point is called as foot of perpendicular of point in 3D space. Now here we can clearly see that this point is foot of perpendicular of this point in 3D space. Now I have explained every concept related to this model, which is three-dimensional space. And thank you. Jai Hind.